Welcome to Ireland. Home to many of the world's leading companies, attracted by its young, highly skilled workforce, business-friendly environment and access to the EU's single market. I'm Nadeira Tudor, and I'm here to discover more about an amazing digital growth story that is responsible for products that are quite simply providing the pulse to modern life. From smart speakers to mobile phones, electric vehicles, kitchen appliances and satellites, I'm talking about semiconductors, also known as computer chips. Many electric vehicles on the road today are being powered by up to 3,000 of them, and global chip sales are expected to pass $610 billion in 2024. And in the age of quantum computing and AI expansion, Ireland's 50-year legacy nurturing the sector is well worth exploring. I'm off to meet Anne-Marie Tierney-Leroux, Senior Vice President of Global Enterprise Technology at IDAIRELAND, the government agency that's been responsible for foreign direct investment since 1949. Now, there's been a remarkable growth in the semiconductor industry here in Ireland. What started it all and how has it evolved over the past few years?
First up, we have some of the best players in global industry in semiconductors that are located in Ireland, to the extent now that Ireland is home to 15 of the top 30 global semiconductor companies here. And that's really, really important for a small country. Secondly, IDAIRELAND works with these companies to help scale and grow them and to grow their businesses. We do that. So the sector employs 20,000 people in total. There's over 100 companies that are operating in microelectronics in Ireland. Just recently, we had the investment by Intel in Fab 34, a 17 billion investment in a really significant state-of-the-art European facility. But we've had a number of significant other research and development investment as well from companies like AMD, Qualcomm in particular, and new investments from Analog as well that have helped position and grow the microelectronics industry more fully. From an Ireland Inc. perspective, what do these companies want? They want support from IDAIRELAND. They want collaboration with academia and with the research centres. But most importantly, they want a talent pool that can scale and grow with their global business demands. And that's what we're incredibly good at.
A critical part of Ireland's role in global semiconductor production has been its universities and research centres. I'm here at the historic Trinity College, Dublin, founded in 1592 by Queen Elizabeth I and the oldest university in Ireland. And today, it plays an important role in high-level research for the semiconductor industry. Headquartered here at Trinity College is AMBER, the SFI Centre for Advanced Materials and Bioengineering Research. The centre is a multidisciplinary and multi-institutional research centre focused on leading advanced materials research and innovation for economic and societal impact around the world. Professor Michael Morris is director of AMBER.
We kind of have a double focus in terms of our research. And the first of those focuses is really on very basic fundamental science, right at the art of discovery, but industry focused in the sense that looking at what might occur, what science is going to enable products 10, 15, 20 years away. So that's the first part. The second part of our research mission is looking to carry those very fundamental research into developing products and technologies in collaboration with industry.
So obviously you are recruiting and nurturing the talent. How important is that?
Our mission is to be world leading, right? Because if you're not world leading in this field, you're not really contributing. So for us, we want to recruit the best talent that we can into AMBER. and then they go into companies to actually lead those companies on their scientific missions as well.
How important is research?
Research is really critical. If you think about what the global problem is at the moment, right? Sustainability and climate change. We won't be able to run the factories in the way we want to run them, that are climate friendly, that are environmentally friendly, without the kind of semiconductors which can enable them to tune themselves to lower emissions. And that global footprint has to be lowered. And that will only be done through a combination of research with academics and industry to actually drive that kind of sustainability. You can't do this work without government support, and the government has really helped us do that. Our last round of AMBER, we took 40 million off the government for 6 years of work. And in the next round, we're asking for around 80 million. So these are big programs. They soak up a huge amount of money, and we've been very lucky that the government has supported them.
Over in South Dublin, UCD is another of Europe's leading research-intensive universities. The university prides itself on being an environment where undergraduate education, master's and PhD training, research, innovation and community engagement form a dynamic spectrum of activity. How does UCD support the semiconductor industry?
Well, our main product, of course, and what the industry is interested in mainly are the graduates. So that's our number one. But also, as academics, we do research, and much of that research is relevant to the industry, and we can license it, and it can go into products, create jobs here in Ireland.
How long did it take for you to understand how to map those courses to the requirements of industry here in Ireland?
Well, we have an industry advisory board. We also have an industry academic body called Midas Ireland. So Midas Ireland has all the top companies in the sector and the universities, and we discuss what are the needs of industry, and then we will react. Master's students take an 8-month placement with industry. So they get industry experience, which is extremely valuable to them. And eventually many of them are employed in the same companies that took them on. And you have the right to work in Ireland for 2 years after completing your studies. Key thing the IDA does is to attract industry into Ireland. So that's in all of our interests, because if we have companies here that are relevant to the research that we're doing, then we can have greater support when we go for grant applications. So IDA, building a critical mass of companies, generates opportunities for our graduates and allows us to do the kind of research and teaching that we want to do.
The first industry trailblazer to come to these shores was American multinational Analog Devices, or ADI, back in 1976. The company set up shop in Limerick, where it remains today.
Analog Devices' decision to choose Ireland as a location in 1976 was driven by the country's talented workforce, pro-business environment, strategic location and focus on innovation. Our CEO Vincent Roach remarked recently that the furnace of innovation continues to burn brightly in Ireland. The Irish government has always been supportive of foreign direct investment, offering attractive incentives that companies like Analog Devices utilise. This supportive regulatory framework made it easier for us to establish and grow our operations in Ireland. Ireland's strategic location within the European Union provided us with seamless access to the European market. This has been vital for our business, allowing us to efficiently serve our customers across Europe and beyond. Over the years, we have established significant R&D operations in Ireland, including our European Research and Development Centre in Limerick. This centre is a testament to our commitment to innovation and our belief in the talent and capabilities available in Ireland.
Hi Liam.
Hey,
Hi,
morning,
nice to meet you.
Nice to meet you.
Nice to meet you. Explain what you're doing here.
We're working in the area of wireless battery management systems. Basically, we work with EV battery packs. Each cell needs to be monitored for voltage, temperature, particularly during charging. That's usually accommodated by a lot of wires. So what we've done in this case is we removed all this wiring, and we've replaced it with ADI radios. That gathers all the information, publishes it back to the manager, so the ECU in the car can know the state of health, state of charge of the battery pack in the car. We're removing weight, removing complexity, makes the adoption easier, but also makes the same battery go further. They're also completely reusable in second life. Say 7-10 years of use in a car, your range might be down to 70%. That's probably not acceptable anymore in the car, but that's perfectly good for energy storage. So attach it to windmills, attach it to data centers, and have maybe another 10 years. It's game changing in that sense.
Travelling south, I'm now in the vibrant city of Cork, often hailed as the culinary capital of Ireland. Its iconic English market has been trading since 1788. It is here, with this rich cultural backdrop, that Qualcomm Technologies has put down roots. The company's products power smartphones and smartwatches the world over. And the company is now looking to drive satellite connectivity to provide ubiquitous 5G.
Qualcomm is a wireless communication company, so we want to connect everything from your phone to your watch to your mobile to home technologies to smart cities. So recently we had a release of a phone, a Snapdragon, that operates with the satellites. We don't have to be connected to the network, we don't have to be connected to the Wi-Fi. That enables us global communication anywhere, anytime in the world. It is designed across multiple sites globally.
And that collaboration is so key, isn't it?
Yeah, we're one global team. Some of the key sites are San Diego, Bangalore, Hyderabad, and Cork. All these teams work together. We talk to India in the morning because of our time zone, and then we talk to San Diego in the afternoon and the evenings.
Can you tell us about Qualcomm's connections with universities?
Yeah, we have a great tradition of university connections. We relied on our local universities, UCC, NTU. We found great talent. Then we expanded into Ireland universities to Dublin, Galway, Limerick. We did presentations, we explained what Qualcomm does, the great technology, the opportunities. The culture is really important. We have 46 nationalities here. Where we're going to go in the next 3 years will be better than what we have done in the last 30 years. Faster, quicker connectivity, better performance, new applications, and AI is the first part, along with cybersecurity and quantum. All those are three key areas. It's going to create new applications, new use cases, new opportunities for businesses to grow.
Qualcomm and ADI sit alongside other long-standing multinationals like Intel, a company that's invested more than 30 billion euros in Ireland and its advanced industrial campus since arriving in 1989. These are huge sums of money. So, what's driving such investment? To get a clearer picture, I'm visiting the Tyndall National Institute, Ireland's largest deep tech research centre.
If you think about society's challenges, the green and digital transition, it's all about how do we produce better lives for individuals, how we provide better healthcare, more sustainable transport and activities and things like that. They all require what we call deep technology or deep tech, which is built on semiconductors and chip technologies. If you think about the cloud, and everybody coming out of the pandemic knew they were using cloud and communication technologies. All of that needs chips. It needs more chips, faster chips, more efficient chips, made in a more sustainable manner. Our role really is to work with small companies, large companies, and new startups to try and help them develop new innovations and bring those to market. We call it lab to fab to app being applications. We're so lucky to have the support of the Irish government and also with our industry partners to be able to do that.
Let's look into the future now. How do you predict the next 5 years?
Well, the semiconductor industry will continue to grow. What we've seen is that governments across the world have been investing heavily. So we have the EU Chips Act, we have the US Chips Act. And those activities will see a significant investment into research and development and the establishment of advanced production facilities. I think that we also have a lot of emerging technologies such as photonics, integrated magnetics, which is really important to reduce the power consumption of semiconductor devices, which is starting to become a major issue, and of course quantum technologies. So I think the future is very bright.
With the sun still shining, I'm heading to Galway on the west coast to learn about a rather special family business. Mbryonics is a deep space tech company specialising in extreme engineering, developing innovative optical systems for telecommunications, Earth observation and science missions. Founded 10 years ago by siblings John, Ruth and David Mackey, Mbryonics is a homegrown industry pioneer. It's pursuing a mission to build the internet in space with its technologies and satellites orbiting Earth and in deep space. The company is establishing a significant manufacturing facility in the west of Ireland following a €17.5 million investment from the European Innovation Council Accelerator. Co-founder, CSO and Chief Operating Officer Ruth Mackey tells me more.
We're creating laser links between satellites. So we make and design very precise optical instruments that can point and track at satellites as they're moving and create the links. We also create the photonics transceivers that actually then drive the data through the system. We design everything and we manufacture about 85% of the components in Ireland. My own background was in a technology called adaptive optics, and this is real-time flexible optics that are used to correct aberrations in systems. But that led on to understanding complexities that were going on the satellite side, and also some of the innovations that were needed there. So there's been a number of years spent to make photonics more power efficient, because everything on a satellite is running off a battery and is solar powered, so you're trying to be as efficient as possible. Some of those innovations that we've made have actually now translated into even data centers on the ground. So we are actually spinning out that technology.
Can you explain how global your business is?
Our customers would typically be either in Europe, the US, or actually in Japan or Australia. So we have really an international market that we're actually operating with, and also an international supply chain. And we have really relied on Enterprise Ireland and the IDA to actually support us in actually government level, even opening up export paradigms that we can actually be based in Ireland and actually export out some of these technologies.
Can you explain how you're encouraging more female representation?
We actively engage as much as possible in recruiting actually a broad spectrum of people. So we go out to universities, we go to STEM events and actually let them know what we're doing, because sometimes it's not always visible, you know, that, okay, so I'm doing a physics degree or I'm doing something, but actually what could I do with that as a job? So for us, it's really important to actually encourage particularly young children who are just very excited and enthusiastic, and anything is possible, you know, that's always, there's no barriers there. So just encouraging that all the way through.
Another company in Ireland at the heart of high performance and adaptive computing revolution is American multinational AMD, which has placed its focus on solving the world's most important challenges. Its technology is embedded across industrial, healthcare, space and beyond. AMD's complex chips help to make cars safer, factories more productive, increase personal productivity and are driving the AI revolution. With a 30-year history in Ireland through the acquisition of Xilinx, AMD is a much celebrated industry pioneer.
AMD have been driving the computing industry for over 55 years. And we've had many industry firsts, in particular in semiconductor technology. In particular, I would focus on one more recent evolution of semiconductors that has been pioneered by AMD, and that's something called chiplets. It has really redefined the way chips are designed and manufactured. If you take a microchip, you can divide that microchip up into separate functions, and they can be implemented as chiplets. Each chiplet can be manufactured on an optimized fabrication process. We then bring the chiplets together and integrate them in a single package. That allows us to create a very flexible and modular chip design process for lots of different applications.
How being an island is a benefit for the company?
Was first of all the modern infrastructure, secondly the focus on advanced technology, and also the availability of talent both locally and within Europe and further afield. IDA have been an incredible support for AMD since our operation started 30 years ago, to the extent that we're now one of the biggest R&D facilities for AMD here in Europe. There's been multiple rounds of investments over those 30 years in collaboration with the IDA. In terms of the most recent investment, that's been 135 million over 4 years in the area of data center, communications, networking, AI, and embedded applications. The AI market itself, that is the biggest growth opportunity for AMD. If you look at data center acceleration on its own, AI is a market opportunity of 400 billion in the next 3 years.
We see the future as bright because Ireland is still and maintains a very strong position as an investment location. We are a member state within Europe. We clearly are very well informed of the developments at the EU Chips Act. And we look forward to working with companies across the world that might be considering their global manufacturing and/or research footprints that might want a place in Europe and that they might want a place like Ireland to call their home.
Thank you for joining me on this road trip. This small island has every reason to be proud of its thriving cluster of semiconductor businesses. These are true pioneers, collectively providing the pulse to modern life.